Hi, so in this video I want to talk about the Pythonic way of iterating over collections. So first we need to understand the difference between a sequence and an iterable. A sequence is an iterable, but it's an iterable whose elements can be accessed via an index. That's really all it is. So for example, a list is an iterable, but it's also a sequence type. If I do L equals 1, 2, 3, 4, 5, I can access elements by index. I can say L0, I could even use negative indexing, and I access the elements of the list that way. Now, other sequence types include tuples, but they're immutable. But as I said in a previous video, I also consider a tuple more as a data structure than an immutable, list. But anyways, you can, however, access elements of a tuple using indexing. So it's a sequence type. Strings is another example of a sequence type. But more general than sequence types are something called iterables. For example, sets are iterable, but they are not sequence types. If you create a set like this, 1, 2, 3, you cannot access the set elements using indexing because there is no guaranteed order in a set. Same thing with dictionaries. Dictionaries are not sequence types either. You cannot access by index, you have to access by key. So in many programming languages, iterating over sequence types, so this is now sequence types specifically where you do have indexing available, and in many languages, accessing data elements of a sequence type is done by using indexing. For example, let's start again. Let's say that I've got this list, 1, 2, 3, 4, 5. And then how would you iterate over that? In many languages, you'd use a for loop, and then if you were like in Java or C, you'd have, int I equals 0, I is less than whatever, and then I plus plus. Okay, so in Python, the equivalent for doing that is by using a for I in range, and then people go the extra step basically of using indexing, right? And so now I'm going to iterate as many times as I have elements in the list, and then I'm going to print, let's say li, and then I'll square it while I'm at it, like so. So they're accessing the elements of the list, they're iterating over all the elements of the list using indexing, okay? So that's fine in languages maybe like C or Java, even probably not even Java anymore. So you might be tempted to write code like this. Now, in order to use indexing to do this kind of loop over here, well, the collection must be a sequence type, right? It must support element access via indexing. So Python, however, prefers the more general concept of just iterables and iterating iterables, where the iterable is a sequence type or not. It doesn't have to be a sequence type like a set. We can iterate over a set, but it's not a sequence type. We can iterate over a dictionary, but it's not a sequence type. So this concept over here, first of all, doesn't extend to all kinds of iterables. It's only for sequence types. And then secondly, this makes the code quite convoluted. It's not easily readable. If we want to iterate over every element of the list, well, that's very simple. We just say for element in L, that's it. And then just print EL squared, like so, like we had before, we get the same result. As you can see, this is very clean compared to this. So that's the first thing. Don't use indexing to, iterate over a sequence type. You can just iterate over the elements directly. And of course, this now applies, the same syntax applies to things other than just sequence types. It's very general. Now, sometimes, and you'll probably be saying, well, but I need to know the index that I'm at currently because I need to maybe modify the value that's in the list at that particular thing. Maybe I've got an if statement, and if something, then I'm going to make a change to the value in the list, otherwise continue. Now, if that's the case, you might be tempted to go back to this approach. Again, that's not Pythonic. If you really need to know the index that you're at as well, then you use something called the enumerate function, which is built into Python. The enumerate function returns an iterator that iterates over the specific iterable, so this isn't restricted to sequence types either, and it includes the index of the element. It's really actually just the loop index starting at 0. For a sequence type, therefore, that loop index corresponds to the index of the sequence type. For a non-sequence type, it's really just, the loop index, and if you need it, then you have it available. So let's take a look at a simple example to show you what I mean. So let's go ahead and create this list. And I'm going to declare this variable here, or define this variable. And I'm going to say enumerate L. So I'm going to get that back. And it is an iterator, right? If we look at the type, well, actually, if we just go ahead and just see what iterator is, it's this enumerate. But that is an iterator. So we can call next on iterator to get the next value in that iterator. And when we do that, we get a tuple back. We get the index value, or the loop index, starting at 0, and then we get the first element of the list. If we call next again on the iterator, then we're going to get the loop index is 1, and the value of the sequence that we passed it, of this iterable that we passed it, is now 2, and so on. So we can use enumerate in a loop this way. We can say for row in enumerate L, and then I might just say print row, like so. And so we get all these different tuples. The loop index, 0, 1, 2, 3, 4. If it's a sequence type like L is, then it's actually the index of the element, and then the actual value of the element in the iterable. Now, of course, we can just unpack the index and the value directly in the loop. We could unpack it here. We could say, index comma value equals row, like so, and then we could print, let's do an F string, and let's just say index equals and value equals, right? So if we have that, and we get the index equals, the value equals. But of course, we can just unpack it directly in our for loop. So we can say for row, for index, comma value in enumerate L. And that's usually the way that you do it. That's the more Pythonic way of doing it. You just unpack and extract right in the for itself. And now you can do whatever you want with it. I can go ahead and now modify, since now I can access L. I've passed it a list. I can access things by index. And I can say, well, that's equal to the value plus 2, let's say, and then square it. Whatever transformation you want to do on that particular element. And then if we print L, you can see that it's been modified. And so I needed to know what the index value was in order to be able to do something like this. Actually, I could have used a comprehension, but that's going to be for a future video. And so you needed this index value, but we did not have to do this style of loop that we had over, where was it? Over here, right here, right? We didn't have to do this for I in range, length of L, and then we have the I, and then we can access the elements that way. We don't have that. It's a much simpler, cleaner syntax to do this over here. Now, sometimes we may need to iterate over multiple iterables at the same time. And again, you may be tempted to use indexing to do this, assuming, of course, that it's a sequence type and that it supports indexing. So let's go ahead and do two lists, which are sequence types. Let's say we have L1 and let's say we have L2, and L2 is going to be equal to A, B, C. And you know what? Instead of doing that, I'm just going to say it's the list. I'm going to take A, B, C, D, E, for example. So I've got 5 elements in L2, right? So if I look at L1 and L2, you'll see that L1 is the list 1, 2, 3, 4, 5, and L2 is the list of the characters A through E. Each of them have 5 elements. So now we want to iterate over those two sequences, those two iterables, in parallel at the same time. So you might be tempted to go ahead and do something like this. For I in range, and then len of, since they're equal, I'm just going to take the length of one of them, and then I'm going to print L1 I, and then L2 I, like so. So, and of course I've got invalid syntax. Oh, well, how about I in, okay? So I get this parallel iteration, and I've used indexing access essentially to get that. Now, of course, if the two lists are not of the same length, let's say that L1 is equal to, again, 1, 2, 3, 4, 5, and L2 is equal to the list, let's say A, B, C, D, so I've only got 4 elements here, then I'm going to have to do something like this if I want to use indexing. For I in range, now what's my range going to be? Well, it's going to be, I can't iterate in parallel over the length of L1 because that's too large. I only have 4 elements in L2. So in general, I'm going to have to take the minimum of the length of L1 and L2, like so. So I'm going to have to do this iteration, and then I can go ahead and say print L1I and L2I, like so. So when we get that, we get 1A up to 4D. So the more Pythonic way of doing this is not, again, to use indexing like this. We can use the zip function to do exactly the same thing. So if we take this over here, and let's start with the A, B, C, D, E. So we have 2 equal length iterables here. And we can say for EL in zip, L1, L2. And of course, the zip function works beyond just L1 and L2 being sequence types. It can be any iterable or iterator. It does not have to be a sequence type. Here they just happen to be sequence types. So we can print that element, and what do we get? Well, we get a tuple that contains the first element from the first list and the first element from the second list. Then the next one is the second element from the first list, the second element from the second list, and so on. Now, of course, again, just as we saw before, we've got the tuple coming back here in the iterating. We can just go ahead and unpack it right away. So we can say for v1, v2, and we can print v1 and v2, like so. And so we've extracted those in the loop as well. Of course, this extends to more than just 2 iterables. Let's say that we have these 3 now. Let's say L3 equals, and here I'll do a tuple, 100, 200, 300, 400, 500. Now I can say for v1, v2, v3 in zip, L1, L2, L3, and we'll just go ahead and print v1, v2, v3. And so you can see that we've done this iteration in parallel now for 3 iterables. Now zip will stop iterating based on the shortest sequence. So we don't have to play with the min function like we did just now when we were doing indexing. So for example, if I take these, like so, then I can say for v1, v2 in zip L1, L2. So this was the same example we had before when we used indexing. We had to muck around with the min and so on. Here, we don't have to. Zip will do that automatically for us. You can see that, I think the previous example had A, B, C, D. So you can see that it stops at D, right? It stops basically based on the shortest of the sequences that are passed in, or the iterables, to be more specific, that are passed in to the zip function. Now, if you want to iterate based on the longest iterable, that's actually possible as well. Python covers that case as well, but not with the zip function. We have to look at the itertools module, and from itertools, we can import zip longest, like so. And this is essentially going to allow us to zip to parallel, iterate over multiple iterables based on the longest sequence. Of course, the thing becomes, well, this one was 1A, 2B, 3C, 4D, and 5. What should it return here for L2? Because that's why zip stopped. It said, well, I can't continue because I've got no corresponding, 1, 2, 3, 4, 5th element in L2. I only have 1, 2, 3, 4 elements. Now what zip longest does by default, it will just return a none in there. So let's go ahead and use, let's say, this example. I'm just copy pasting that from the notebook that you can download. Link is below, it's in GitHub. So here I'm going to do for EL in zip longest, and we're going to pass it L1, L2, and L3. And let's go ahead and just print the element. So again, that's going to come back as a tuple, right? And you can see we have 1A, 100, etc. And then for the 5th one, we have none and none. Now, of course, we could have just unpacked this v1, v2, v3, just like we did before. So as you can see, this default fill value is none. But we can specify a custom one if we want to. And all we need to do here is we need to use the keyword argument fill value and make it whatever you want. Here, maybe I'm going to make it a string. So I'm going to say, well, when it's, when I've run out of elements on any one of those, go ahead and fill out NA. So as you can see now, instead of none, we get our custom fill value over here. And of course, as I said, we can unpack this directly. So we can say for v1, v2, v3 in zip longest L1, L2, L3, and then we can just print v1, v2, and v3, like so. Okay, so far, I hope I'm convincing you that we really don't have to use indexing. First of all, it's not generic because it doesn't work across all iterables. And secondly, the more Pythonic version of doing it this way is much clearer, much more expressive than using indexing. Now, what about looping in reverse order? Let's say I've got this list, 1, 2, 3, 4, 5. This is another case where people are very tempted to, well, I'm going to have to use, indexing in order for me to loop backwards on this thing. So how would they do it? Well, let's say for I in range, and then we're going to take the length of L minus 1. So we're going to start at that last index, and then we're going to go up to, but not including -1. So we're going to go from, in this case here, the length is what? 1, 2, 3, 4, 5. The length is 5. What's the last index? It's 4. So it's the length of L, which is 5 minus 1, which is 4. So the range is going to start at 4. It's going to end at 0. And of course, we have to go backwards. So we've got to go in steps of -1. And then I can go ahead and say print Li, like so. And I've looped essentially over my list in reverse order. Again, this is difficult to read, and this is non-Pythonic. And it does not extend to iterables in general. It only works for sequence types. So a better way to do this might be to use slicing. And if you're thinking in that direction, that's good, because this is definitely more Pythonic. We can do this. We can basically specify a slice that starts at the end, ends at the beginning in steps of -1. Much more Pythonic than this over here. Okay, and then we can print the element. So we'll get the same result. So this is a good step in the right direction. But this over here, this slice actually creates a new list. It made essentially a new list with the elements reversed in it, right? I could say L equals, well, let me not use L, let me say R equals L, and then, square brackets, -1. You can see that R is a new list. My list L is still there. R is not L, right? So we've created a new list. So we've introduced extra memory overhead only because we wanted to iterate in reverse. So that works, but there's no point in doing that overhead because we have a reversed function. Most iterables in Python, not all, but most iterables in Python implement a reversed method that can be used to iterate backwards over the iterable. And when you define your own iterables using your own custom implementations of the iterator and iterable protocols, you can also implement the reverse protocol. I discussed that in my deep dive series. But essentially, that's a much more effective way of doing it because usually that reversed implementation does not use or doesn't create a memory overhead. So if we have L, which is here, if we look at the reversed, if we call the reversed function on L, you can see that this is an iterator. And again, it's going to be a lazy iterator. It's not going to create the whole thing in memory and then return it to us. It would have returned it here. Instead, it just creates an iterator, and we can now iterate over that. We can say for EL in reversed L, print EL, print the element. Oops. And so we get that. So as you can see, it's an iterator, and it doesn't compute and store the entire reversed list. And of course, it works for more than just sequence types, as I've mentioned, as long as, and if you write your own custom iterators, as long as you implement the dunder reversed method, you have, access to this way of reverse iterating something. All right, so this is how you can avoid using indexing for a lot of iteration problems that you might run across. As a general rule of thumb, using indexing for looping over iterables is usually not considered Pythonic. There might be cases where you absolutely have to. That's fine. I'm not saying that these rules are, 100%. There's always cases where, no, you're going to need to use indexing for some reason. But in general, what I find is that people are not using these built-in Pythonic ways, these idiomatic ways of looping over collections. So just keep in mind how we use for loops and functions like enumerate, zip, zip longest, reversed, and so on. Thanks for watching.